Hi guys, welcome to your Unit 4 review, Scientific Notation. So each of these problems goes through similar problems to what is on your test, okay? Some of it I go through and give examples, others I kind of give you hints on what you should make sure that you study and go back and review. You can always go back to your lessons. You can always go back and watch the other videos that I've created if you found those helpful as well. But I would encourage you to write this down, pause the video, take your time, and use it on your test. Okay, it's an open notes test, so take your time. There's no reason to rush. Okay. Number 1 is 2.37 times 10 to the 11th written in scientific notation. So the answer is yes. Yes, it is. Okay, and one thing to think about with that is that the coefficient is greater than or equal to 1. Oops. I'll say, let's see, I'll just write the coefficient. Okay, it's in between here, and it is less than 10. So it has to be between 1 and 10. Okay, it can't be 10. It has to be less than that, but it's got to be right in between. Okay, so really there's got to just be something in that 1's place value and with any decimals following. Okay, and then it's also got the power of 10 to an exponent. So that's the other part of the scientific notation that we need to consider. Okay, so number 2, it says we use scientific notation for... And I don't want to give you the answer because otherwise I'm just giving it away. Okay, so look in your lessons and older videos to see why do we use scientific notation? What kind of numbers do we write with scientific notation? Okay, so that's one I'm not just going to give it to you. Okay, number 3, a scientist is looking at 2 bacteria. Sample A is 3.1 times 10 to the negative 5th meters wide. Sample B is 8.2 times 10 to the negative 8 meters wide. How many times bigger is A than B? So, with this one, we got to think about what we need to do, right? So, in order to figure this one out, we are going to, to figure out how many times bigger A is than B, we are going to divide. We're going to say we've got 3.1 times 10 to the negative 5th divided by 8.2 times 10 to the negative 8. Okay? And then with that, we're going to divide the coefficients. So let me get my calculator up. We're going to divide the coefficients. So we've got 3.1 divided by 8.2. Okay? That gives us... Did I do that right? Just making sure I got my stuff right. That gives us about... Let's see, this part right here. I'll go like that. It gives us about 0.378. It's going to go on for a very long time, so I'm not going to do the whole thing, but that gives us at least the idea. Okay? And then what we're going to do is we're going to take the exponents, and since we are dividing, we're going to subtract our exponents. So we've got 10 to the negative 5 minus negative 8. Okay, so with that, negative 5 minus negative 8, well, whenever you subtract a negative, you end up adding. So really it's like saying 10 to the negative 5 plus 8, which is 10 to the 3rd. Now the issue with that is that 0.378 is not in scientific notation. So we want to then sorry, I'm just writing them together. Ten to the third. And after we do that, we want to, we need this to be between 1 and 10, right? So we're going to move our decimal one spot to the right to give us 3.78. Okay, and then what that does is we need to then take one away from our exponents, okay, giving us 3.78 times 10 to the second. So, and with that, if we wanted to, we could leave it like this, or we could also move our decimal 2 spots to the right to get 378 as our final answer. All right, but we could leave it like this to be times bigger. Okay, so I know those are complicated, there's a lot to them, but hopefully that will help. But also go back and look at the division lesson. I believe it's lesson 9 in your unit. Okay, number 4, that's another one. I'm not going to give away any answers, but you can look at your notes or go back to lesson 8 for help on that one. Okay, number 5 and number 7. How do we write a number in scientific notation? Well, in scientific notation, remember that coefficient, right, or the decimal value needs to be between 1 and 10. Okay, multiplied by a power of 10. Okay, so that at least gives you the basics to help you with both of those problems, number 5 and 7. Number 6 says a factory makes 3.267 times 10 to the 9th items per day. They need to share these equally among 5.445 times 10 to the 6th stores. How many items will each get? So if they're dividing them equally, that means that we are taking 3.267 times 10 to the 9th, and we are dividing that among 5.445 times 10 to the 6th. So, with that, come back to the calculator. We've got 3.267 divided by 5.445. Okay, that gives us 0.58822. We'll go with that for now. Okay, and then we need to subtract our exponents. So 9 minus 6. Okay, so that would be 5.8822 times 10 to the 3rd. Okay, and then really from here what we could do is we could, it's written in scientific notation, or if we did move the decimal over, times 10 to the 3rd, we could just say 1, 2, 3 over, giving us like about 5,882 items each would be your final answer on that one. Okay? Alright, on number 8, I want you to go back and review lesson number 3. That's where you're going to find help with that one. Okay, if I do it in here, I'll give away too much. Number 9, when comparing numbers, make sure they are both written in scientific notation, and then you can compare the coefficients and exponents. Okay, so that's just like a little bit of information on number 9 that will hopefully help you. And then number 10, add 3.7 times 10 to the 4th plus 6 times 10 to the 6th. Okay, and I probably didn't give myself enough room on these, but I'll try to make it work. So one way to do this, and one thing I like to do, is I like to write them, like, take one of them, write it in standard form, and then convert it back to a form of scientific notation, because part of my goal is to have my exponents be the same, right? So to do that, let's see, I'm going to take this one here. If I take 6 and I take it to the times 10 to the 6th power, that means I'm going over 6 times. Okay, and in this case I would fill all of those in with zeros. Well, in order to have it go to the 4th power, right, I would need to move it back 4 spots. 1, 2, 3, 4. So this is like the same thing as 600 times 10 to the 4th. Okay, now with that, then we can say, okay, well, let's go ahead and add our coefficients. We can have 600 plus 3.7. That gives me 603.7. And then we have it times 10 to the 4th. But my big red flag right here is that it's not written in scientific notation. So once again, I'm going to move my decimal 1, 2, 3, 4 spots over, giving me 6037, and then 3 more zeros. Now it's written in standard form, and then I can convert it back into scientific notation. So going 1, 2, 3, 4, 5, 6 over, giving me a final answer of 6.037 times 10 to the 6th. Okay, that will be your final answer. So that's just one method. There are others that are discussed in your lesson, so do whatever one makes the most sense to you. For number 11, choose the best option. So think about the uses of scientific notation. So if you remember what we use them for, then you'll be able to answer number 11. And then number 12 is a short answer question. And so it just talks about using scientific notation with very small things and very large things. So I want you to think about, why do we use it, right? And your answer needs to be in 1 to 2 sentences. So make sure that you're answering in complete sentences on that one. Okay? So hang in there, reach out for help if you need it. I know this is a tough unit overall, but I'm here to help if you need me. Okay?